Hello! Today I'd like to present my Liora DevOps final project, and I want to start by showing you the application that we're deploying. This is an application called Anchor that I have vibe coded, created to help me study. What it does is quite simple. You just type in a subject and the first study date. Then you click Generate Dates, and it will generate you dates at which you need to review your lesson. This is based on research that helps to anchor knowledge in your brain. You can then download the file and put it in your calendar to help you put alerts or whatever you want. So to deploy this application, we of course have made different repos and a pipeline. So let me show you how this is organized. I've organized into 3 different groups here: platform, project DS, and templates. Platform is, of course, the Terraform files to deploy this EC2 instance that the site runs on, EC2 instance on AWS that we can check out later. So this is the main with all the details for the routing, the VPCs, the different networking requirements, as well as a script here, the user data that will automatically install, well, first update, install, then it will get K3s, sleep while K3s is set up, do some configs, install Helm because we have the Helm charting later on for the GitOps part, install Argo CD namespace, Argo CD, as well as K9s, which I use for monitoring the cluster. I will show you all of this later. We of course have the variable files, and we have the state, which is remote in an S3 bucket. That's here. The state is right here in the platform up Terraform state, so that we can have remote state and control it easier and back it up easily. So this is for the platform parts. The whole site runs on one EC2 T3 medium instance, which is run with a simple Terraform build. Okay, now we have the main project. So there was version 1, but of course we are on project DSv2 now, and the manifest repo, which is used for the GitOps that we will see later. So in the main repo, we have, of course, the different application folders, the logic, the testing, and we have the Docker file, as well as, let's see, the Docker file. So this is a multi-stage Docker file. First part here, we have the builder that is created, and then in the second part, we have the actual, image that uses the builder, as we can see from here. Up, copy from builder. So this makes it a bit smaller and cleaner. The pipeline. This is how I build my pipelines now professionally for work. I like to have this little bit, which is my favorite thing so far about pipelines and CI/CD, which is the components. So this pipeline, as you can see, is quite small. Each stage is actually very small, and that is because it uses components. It goes to pull the logic from another repo, which I'm going to show you next, which makes the pipeline cleaner. And in the actual jobs, we only need to have the important bits. So this is not here using a component, this one actually, but from here we see that we have the use of components. So how do we see that? We see this we see this right here. So here we have the build component, which I'm now going to show you. Oops, nope. In the templates, we have the components. Here we have all components. That includes all the components, as you can see, and which makes it cleaner at the top of the pipeline to just have one all components here instead of a list. And the separate components are here. So we were looking at build. This is the logic and the code for build that we see extended here, .build. To keep things as clean as possible, I've also put the rules as components. We can see them right here, pipeline rules. So these are the different rules that we can be using. And we see that this one uses pipeline rules mr main tag. So this one is pipeline rules mr main tag. So if the pipeline is a merge request, main, etc. So this allows the pipeline to be as clean as possible. And then we see that we can really immediately see what variables are used for that specific job, instead of having a bunch of code and getting lost inside the pipeline. Okay, we can see that this pipeline is in multiple stages. We have the pre-stage, which includes the unit test plus all the first test, the secret scan, the static application security testing, linting, hadolint for the Docker file. We have build push, security scan once the image is built, the push of the image, deployments, health checks, rollbacks, integration, backup. So we're going to go see that on the actual pipeline because it's way easier to see. But before we do that, we are going to do a little modification. So here is the pipeline. In order to get a fresh one, we're going to change the version. So here in image version tag, we're going to just increment it by 1 so that I can have a fresh pipeline. Here we see up, so git add up, git commit. There we go, and we are going to push this. Okay. And voila, we have pushed to our repo. And now we will have a fresh pipeline starting. So the first part is the pre, as we said. First, the unit test. Well, they're in parallel, but the unit test runs to test the code logic. Okay, we can let it do its thing while we go to see. So the secret scans looks into the code to see if there's any API keys, passwords, tokens, or other secrets that have been committed. We see here that there are no leaks. The scan is complete, so we are free from any secrets. The hadolint checks the Docker file to see if there's any security issues, anything that is wrong, and generates a JSON report that we can find in the artifacts. So here we have the hadolint. We can check the JSON report to see what it tells us. Okay, and we see that it's empty, which is normal because there is no problem, nothing to report. If there was something to report, it would say a number of errors. We also have the linter, which is checking the Python code. All linting checks have been passed. It checks all the different files that we see here for the application. Again, generates an artifact, which we're going to check out right now. And we see that there's no problem. The code has been rated 10 out of 10. If there was a problem, then there would be a list. You need to do this, you need to do that, which would make things easy to change. Okay, in the pre, we also have, so we said the SAST, so static application scanning. We can see that because this is the free version, it has there's the basic SAS scan, which is successful, but we can enable rule sets to customize what we want it to check. And finally, we have the unit testing. So here, the unit tests have checked the 3 files. It has passed all the tests, so it tests that there are the right number of anchors, that we can extend, and that the ICS structure is correct. Unit tests are good, and the build runs. Oh, this is the build of the image. So we see that the Docker file image is built. Everything is there. It makes it as an artifact here, saving image as artifact, instead of immediately pushing it to a registry, because it first is going to run a few tests on the image. So first it will run a security scan, which is currently happening. And the security scan is going to check that everything is okay with the image, that there are no critical vulnerabilities. So we here on the pipeline, we put it in the security scan. We can see that we have here the severity. So it will only fail on critical, because there are, unfortunately, because of using Streamlit and everything, there are some high vulnerabilities. So I only failed it on critical for this test. And we see here that the image is being loaded, that it is looking through everything using Gripe. So before I was using Trivy because this was first made 2-3 months ago. So I was using Trivy, but then recently, about 2 weeks ago, I think, Trivy was hacked and vulnerabilities were found. So thanks to the news, I changed to Gripe to get a better scanning and not have the vulnerability. So here we see that the scan report is created, Gripe report JSON, which will then be saved as a JSON. Takes a bit of time, unfortunately, but let's go back to the pipeline while this finishes. So the security scan is happening. The next stage is going to be an end-to-end test with Playwright. So this is something I discovered thanks to some devs at my company. Playwright can be used to load the application into a browser and do automatic tests on a browser. So this is good to test the UI. In our case, because we, as we saw before, have a very, very simple application and we want to make sure that all the UI elements are present, we have a Playwright test that we will see happening that will test different elements of the UI, like that it's the correct tab, anchor method scheduler, the correct title, and that the button generates, that this button here, that this button here, generate dates, is appearing. So let Playwright do its thing, and then once this component has passed, we will have the push phase, which will of course push the image, finally the artifact, into the GitLab registry. So while this goes on, I will explain why I chose GitLab registry. Originally, I had things running with another EC2 instance that was running Terraform. Sorry, that was running Harbor for the image registry. It was interesting, but after a while, I realized that maybe it was unnecessary costs, because it cost me, of course, to run an extra EC2 instance for the container registry, the Harbor one, and it would, and I found that the one that we have here on GitLab is also very good. Okay, so now we are having everything that is going on with the Playwright test. So the image has been loaded, Streamlit has started. We see that Streamlit is okay with a little health check. The PyTest playwright tests are running with the internal local URL. So this is still, of course, not the normal public URL. It's just a test before the push to make sure that our image is ready. So we see here, so opening home, the home is open, the title is Streamlit. We have the tab title here, which is method anchor scheduler. That's okay. We have the heading, anchor method generator. So we see it here, anchor method generator. And finally, we have the generate button, generate dates. So the test is okay. We are good. And here we can now manually push the image to the registry. So I put this manually because if I want to check that all of these things, everything is good, all the tests have been good, I can go to test everything before actually pushing the image to the registry. So we're gonna have the push. In the meantime, we can go check out the registry. So this is my registry. Here we have all the different versions, and we see that that we're going straight to 1.7.1, which is okay, I guess. But yes, these are all the different versions. And one way that I could make this better is I could have git tagged the different versions and be able to see quickly what they changed, because here it's kind of hard to see what is different between each version, and I have to go to the commit history to see that. Okay, so we are now pushing the artifact, and the image has been loaded as an artifact. It's being pushed to the registry that we see here. So project is1, project is2, which is here. Project DSv2, and the image has been pushed. So now if I refresh here, I see that the latest image 1.7.1 is here, published 14 seconds ago. So now that the image is ready, we can have the automatic deployment to dev. So this is going to go deploy into the cluster, the deploy dev job. Okay, so let's let it do that. And while it does that, let's go check out our EC2 instance. So here we are into the EC2 instance, and I like to use K9s to look at what is happening in the cluster. It's a very good interface that I use regularly at work. Just time that it loads up, and it will allow me to see the different elements. It's being very slow for the demo, not very nice, maybe because this is running at the same time. So we see that all the different steps are happening. We have the kube config that is confirmed. We check that dev namespace is okay. We have the manifests, the deployment is analyzed, and everything is being deployed. Now hopefully, nope, still not. Okay, being a bit slow, sorry. So we're still deploying, sorry. So we see that the old replica is being terminated. Okay, so here this is prod, but now we want to go see dev. So I'm going to click on 3. It's being very slow. Okay, and here we see my deployment. Okay, so we see the old instance is terminating, and the new instance was deployed 2 minutes 22 seconds ago. Okay, so this seems to be up and working, which is great. We can see the logs. Okay, still booting up, but once it's good, the logs will appear. So here the job has succeeded. We see that the image is running, and after that we have a health check that is going to check if the image is okay automatically. So we see here that the image is okay in the cluster, but we want to also check automatically what's going on. So here we have we want to check for the tag 1.7.1. It's going to wait up to 300 seconds. And here we see that things were being a bit slow, but it's verifying. And once the image is actually ready and running, we see that there is a .env that is written, health check OK. That will then be used by the next job. No rollback. That's, as we see here, we have here, okay, so the health check dev is okay. The end was passed, the variable was passed through the GitLab environment, and so the rollback is skipped, which is great to not run it. So we have a check, there was no rollback, check, there was no rollback. Okay, so that is for the dev. Everything is good in dev, and we see it right here. We have the logs, the image is ready, great. Everything is running, so we are good to go on to the next bit. We can check the version here. So I press D to check the version. And we see that the version is the right tag, 1.7.1 in the deployment, so everything is okay. Right, we can deploy staging now, so it's going to do the same steps. It's going to deploy staging. We can go C into staging, so now we go into the staging, or staging here, and S for namespace, go to check. Very slow today. Okay, and we can go to staging down here to check on our staging environment. So we see here that we have a 5 days old pod running, and once the deployment job in the pipeline will be done, then this will be replaced with a fresh new image. So everything is going on, it's applying. Okay, so here we have the new deployment. The container is creating. Okay, it's running, and the previous one should be terminating soon. So this we can refresh to see up. So still deploying. Yeah, computer is being slow today, especially for the demo. So here we see from the point of view of the pipeline that it's waiting for the deployment to finish. So because this is still not ready, So I see that the instance is having a little bit of an issue. Okay, we're back. So here we see that the old instance has terminated and the new instance is now running. So we are okay. The job has succeeded, and we are moving on to the health check, sorry, for staging. So same thing. It is going to go check in the cluster. Okay, we're good. Now it seems to be going a bit faster. So we see that it's waiting up to 300 seconds. We saw that the tag is correct, 1.7.1, ready running. And again, the .env is written. The rollback stage checks for the .env. Checks for the .env. And we see now that we are good. We have checked for the .env. The rollback has been skipped. And the health staging variable is there to tell us to skip. Okay, so now we are getting to the good stuff, which is first integration test for staging. So the integration test is the same as we saw before, is playwright, except this time it checks on the running pod that everything is okay on the actual running pod with a curl. So actually, sorry, no, this doesn't use playwright here actually, because playwright would need a URL. For staging, we do not have a URL, and therefore it's going to do a curl from a sidecar to check that we have a 200 code from the pod. And the pod says yes, all is good, and we have a running pod here. As we see, we can check out the logs, and the logs are saying that everything is okay. We're now ready for deployment to prod, which we're going to do immediately. Now, deployment to prod is a bit different because this is, as we will see now, GitOps. So instead of directly pushing the image to kubectl, instead of directly pushing the image to the cluster, we can see here that we are going to first check so that we have a new tag. We're making an updates in the charts with Helm, the Helm charts, to the value, which is the image. Here we have the current values, which was 1.6.0, and we are going to change it to 1.7.1. We also check that we have the right Datadog agent host. We're committing the change, and we see that we have a hash here with an update. So this has updated here in the manifest repo. We see that we have 51 seconds ago. We have a change in the values. So update anchor image up, and we see that here the image tag has been changed to 1.7.1. So now Argo, which we see here does not work, Argo CD is going to go do its work. So we need to launch it so that we can see. I have here a little script to be able to automatically see Argo. So now when we refresh, we have Argo. I need to get the password. Okay, so let me go to get the password to Argo CD, into the secrets. We're going to do this initial secret decode, and here we have the secrets that we need. Hopefully it's okay. Okay, and we can sign in to Argo CD. Up, we don't have the right. Okay, because of some spaces. Okay, now we're good. So we see here that we have our application. So anchor prod, it's now syncing, progressing, healthy, synced. So we see that Argo CD did its work. And now if we go back to prod here, number 3, we have anchor prod, the deployment with fresh image. We have 2 replicas, 1, 2, because it's prod to keep it safe. So we have, 2 replicas that are now running 1.7.1. And as we have seen before, same as in the previous stage, we have a health check that was run. So here, because this is GitOps, it might not be immediate. So we have a poll mode Argo CD GitOps up to 9. So it checks every 30 seconds. Okay, we want this, but right now we have this tag. So we are waiting. 1, 2, 3, 4, and we see that after 134 seconds, we finally have the right version, 1.7.1. All the conditions are met. We are ready. We are running. We have the tag. So the health check is passed. The .env is written to true. And again, we can skip our rollback. Okay, so here we have rollback skipped. Okay, great. And we have the integration prod, which this time is using Playwright, as we can see here, Playwright integration with the actual URL, anchor.flowshy.com. We are checking as before that we have the right URL, that we have the tab title, anchor method scheduler, we have the heading, we have the button, everything is okay. Here is our anchor method generator up. We don't have a lesson, so voila, we generate our dates. And we are good, everything is working fine. And finally, so we deployed to prod. We have our 2 pods running. And now we can check out the last few stages that we have. So here we have a backup. This backs up all the configs, everything that we need, so we can run it. And we have here a test K3s, so let's do that. Let's run it and let's back up. And we are going to go to the backup to see what the backup is doing, and then go to see the K3s test. So the backup is going to send into the S3 bucket that we saw before the different config files. So here we have configs as a tarball. We have the log of the backup to say everything is okay. We have different backup reports, and we have the full bundle of the repo. So this is the whole repo, all the repos, in fact, that are saved here in case we need to backup, in case we need to, disaster recovery, get our stuff back. So it's doing it now, again, being a bit slow, but it's okay. And there we go, we have passed. So we see that we have the AWS credentials, which are here in a variable. So the AWS access key, which is masked and hidden. The different variables are here. So we have the AWS credentials, the GitLab token is okay. We see that the right backup bucket, project DSv2 backups, is selected. It's project DSv2 backups, okay. And everything is backed up. So the log files, the configuration files, the repositories are backed up. The starting container images are backed up. The K3s cluster is backed up. Everything is backed up in the different configs. And finally, so this is a To test if there's ever a problem with the EC2 instance, we have a little script that tests everything. So the namespaces, testing that the namespaces are here, dev, staging, prod, Argo CD. The cluster connection is okay. We have the different URLs and IPs of the Kubernetes elements. Here we see that the different namespaces have the right permission. So here off can I get pods, so to see if my kubeconfig allows me to see what is in each of these namespaces. And finally we have of course the different nodes here. There's only one. The namespaces are okay, everything is okay, the connectivity is good, so this is a successful test. As we can see, the full pipeline is passed. The deployment is successful here. We have the logs. Okay, this is when we have a problem getting the file, which is okay. Everything is good, and the website is working fine. Okay, so finally, once we have, of course, everything deployed into prod and we are happy, we need to monitor. And in order to monitor, we have made here a Datadog dashboard where we see all the info that we want to see. Okay, so here we have the number of pods that are running in prod. So we see that, of course, when there is a deployment, there is a higher number of pods, for example, here because of the previous ones, and the normal number, which is 2. The API usage, so here we have 1 request. This is the EC2 system information, the I/O wait time. So for example, we see here that there was a little bit of a spike, the CPU usage, system load, memory. This is the pods overview for different namespaces. So we have the Argo CD namespace, default namespace where there is the Datadog information, dev namespace, and of course staging namespace. We have the total number of pods, the CPU that is used for the whole cluster, the memory that is used for the whole cluster. Here we have the traces, so we can have, we put in the code different traces that we can see what's going on. We have the latency, we have different requests that go through, and we have here, this is the same as this, the request, but just when they were run. And finally, we have the different monitors. So for example, 14 minutes ago when we were struggling because I'm cheap and I only have a T3 medium, we had a high usage for CPU 14 minutes ago. We also saw that there was a system load that is high and the memory space. So basically this whole instance needs to be upgraded to a better EC2. We can also see that we have disk usage high if we need, network traffic is high, network traffic sent is high, and of course if there is a crash loop, an alert is sent to my email, and then I will act. Okay, so that's it for the project. We saw everything. We saw the app, we saw the different repos that we have here in the groups, the platform with the deployment of the K3s on the EC2 instance, the repo for the app, and of course here the components. We saw our Argo CD installation and monitoring setup. Thank you for watching. Bye-bye.